On page 60, we need to factor the bottom, and that's a clean set of factors. So x squared plus 3, x squared plus 1. So that's not bad, right? Because it's trinomial quartic, it cleans up kind of nicely, right? So what I'll have to do is write this as, we're looking at two quadratic factors in the denominator. We're going to have to write this as a set of linear numerators. So let me rewrite this. Let me get my denominators involved. And I guess I don't need these anymore. So a linear numerator would take the form of y equals mx plus b, the mx plus b part, but we'll use a1 and a2. And then since we've already used a1 and a2, we'll use a3 and a4. So the first denominator is going to be x squared plus 3. Oop, I don't need parentheses there. The second denominator is going to be x squared plus 1. All right, so now I'm going to multiply everything by that common denominator. All right, and that common denominator again, x squared plus 3x squared plus 1. If only it was minus 1. Why would that be helpful? Well, it's funny you should ask. If it were x squared minus 1, then it would be factorable to x plus 1, x minus 1, and give us linear denominators, which would give us constant numerators, which would make the algebra, ideally, a little bit easier. All right. Good question. All right, so nice cancellation on the left-hand side. That should happen every time. If it doesn't, you're doing something wrong. All right. So we're going to multiply the first fraction by our common denominator, and that's going to cancel out the x squared plus 3's, leaving us with a1x plus a2 multiplied by x squared plus 1. And then we multiply the second fraction by the common denominator. That cancels out the x squared plus 1's, leaving us with a3x plus a4 multiplied by x squared plus 3. All right, so distributive property, a1x cubed plus a1x plus a2x squared plus a2 plus a3x cubed plus I'll write the 3 first, 3a3x plus a4x squared plus 3a4. Okay, so anything with a power of 3 gets associated with everything else that's got a power of 3. So a1 plus a3 would be equal to 1. All right. Anything with a power of 2, same deal. So a2 plus a4 is going to be equal to -2. Anything with a power of 1 for x, same deal. a1 plus 3a3 is equal to 2, and then everything else, anything that remains, would have to equal -3. All right. So with systems of equations, we can kind of piece all this together. These two. I will negate the first one. So negative a1 minus a3 equals negative 1. Then I'll have a1 plus 3a3 is equal to 2. Put it together, and you get 2a3 is equal to 1, which means a3 is 1/2. Which means a1 is 1/2 because a1 plus a3 has got to be equal to 1. If one of them is 1/2, so is the other. All right. So then, using that piece of information, I can take this one. Actually, no. I was foolish. I already used that. I could use this one. And by this one, I mean neither of those, because neither of them have a1s and a3s in them. So let's do what we just did, just this time. Oh yeah, I see. a2, a4. Let's negate this one. And you've made a nice looking arrow there. Let's just do it this way. Okay. Got there eventually. Equals 2. And a2 plus 3a4 is equal to negative 3. So we're looking at 2a4 is equal to negative 1, meaning a4 is negative 1/2. And so I have the relation here that says a2 plus a4 is equal to negative 2. So if I know that a4 is negative 1/2, a2 plus that is going to be equal to negative 2. I'm going to get negative 3/2. So a2 is negative 3/2. So after all of that, we can now come up with the integral. Alright, a1 is 1/2, so I have a 1/2 x minus 3/2 over x squared plus 3, then plus a3, which is 1/2 x, a4 is negative 1/2, so minus 1/2, over x squared plus 1 dx. Alright, so we're moving along here. Now it's just a question of, okay, well, now how do I integrate this? It's similar to what we just did. It's just a question of how it's all going to play out in the end. Alright, well, the first thing I would do is look to see if the derivative of the denominator is the numerator. If that's the case, then we have some natural log stuff going on. The derivative of the denominator is actually it's part of the numerator. So that's telling me I should be looking to split this up. So 1/2 x over x squared plus 3 minus 3/2 over x squared plus 3 plus 1/2 x over x squared plus 1 minus, let me move it over, 1/2 over x squared plus 1 dx. Alright, so actually I can move all this stuff over, create some more space here. Alright, so just looking at this, I see the derivative of the denominator would be 2x. Alright, well that's 4 times what I want. So let's correct for that with a 1/4 ln x squared plus 3. And just verify whether you do it on paper or in your head. Natural log of x squared plus 3 would have a derivative of 2x over x squared plus 3. If you multiply the 2x by a quarter, you get 2/4, which is 1/2. Alright, so then this I'm going to hang on to. You know what I'll do is just kind of chuck it off on the side here. This one, I think we can do the same thing because the derivative of x squared plus 1 would be the same 2x. A half, again, is a quarter of what we have 4 times what we want, so we want to correct for that. So 1/4 ln x squared plus 1. So we need the antiderivative of this, and we need the antiderivative of this to kind of fill in the remaining pieces. So this would fill in this piece, and this would fill in this piece, and then we'd have our plus c on at the end, and then we go on our merry way. All right, so it's just a question of, all right, so what's it going to take to get this done? Well, this one should be pretty easy, actually, because if we look at the arctangent rule for arctangent, the antiderivative of du over 1 plus u squared is inverse tangent of u plus c. All right, so that's pretty spot on. All right, so if we factor out the 1/2 and the -1, we would actually have it. So we're looking at -1/2 dx over, well, the integral of dx over 1 plus x squared. That is the arctangent rule. So minus 1/2 inverse tangent of x. All right, so we're good to go there. This guy over here is a little bit of a different story, all right, because we get that plus 3. Now again, different ways to handle it, but the way we've been covering it, learning about it, has been using, I don't even know what I just said there, trig substitution, so that's what we're going to do. We'll learn how to fit to rules, but for now, we're going to just stick with what we know. All right, so again, this has got a tangent look to it. So I'm going to draw a triangle. The A is a radical 3, all right, because it's in the form of a squared plus u squared. So x is going to be equal to, u is going to be equal to x. I mean, in the end, it wouldn't have mattered, but just to be consistent. So x radical 3, and then we would have the square root of 3 plus x squared. Now remember, the trig substitution technique has radicals in it, so I got to create the radical and then correct for that radical that I created. All right. Oop, where did that come from? Undo. There we go. So tangent of theta is x over rad 3, which means x is equal to rad 3 tangent theta, which means dx is equal to rad 3 secant squared theta d theta. You do these problems often enough, you start realizing the similarities, and then you say, oh, okay, I can just do what I did the last time I did this problem, but I'm just kind of going with the approach that it's a blank slate every time. All right, and so the other ratio would be, or near blank slate, radical to constant, so that's secant, because that's the hypotenuse over the adjacent. Oh. So radical 3 plus x squared is going to be radical 3 secant of theta. All right, so I can make my substitutions now. So I'm going to have, I got the negative, and I got the 3 over 2, but that dx, I'll just put that up with the 3 over 2, is now radical 3 secant squared theta d theta. I realized belatedly when I made that stray mark, I lost my power of 2, so let me fix that. So that radical 3 plus x squared gets replaced with a radical 3 secant theta, which is going to get squared, all right? So radical 3 squared is 3, so secant squared theta. So secant squared theta goes away, the 3 goes away, and so we're looking at radical 3 over 2 integrated, and that's going to give us radical 3 over 2 theta plus c, and just like every other time, we need to pull a theta out of this, and so the good choice would be the original ratio, giving us theta is equal to the inverse tangent of x over radical 3, and so that would replace out my theta, and so now we have this missing piece, which is going to be negative. We pulled the negative along for the ride, so this negative is fine. Radical 3 over 2 inverse tangent of x over radical 3 plus all this other stuff. And so that would be our final answer.